The latest Cosmos DB on .NET SDK features change feed, batch insert, transactional processing, bulk insert of items. It's going to make your life easier and operations run faster. Join us on another episode of On .NET. Welcome back to another episode of On .NET. We're continuing to look at underdog features of the Cosmos DB .NET SDK. I'm your host, Jeremy Lickness, and I'm here in the studio with Matías from the SDK team.
Thank you so much again.
Welcome back. It's like we wore the same outfit and everything.
Yeah.
It's great, and I don't think this needs any further introduction. We've talked quite a bit about Cosmos DB. We're diving into the SDK, and we have some pretty incredible features and examples to dive into.
Some new features, and let's jump into the code.
Yeah, I was talking to you earlier about this first one related to change feed. There's a lot of gears turning in my head on how I can use change feed in some of my applications. Why don't you share that with us?
Sure. So basically the change feed, just to give a small conceptual description, is kind of like a timeline where we have all the items that have been created inside the container across time and their update operations. So what we can do with the change feed is basically create applications that react upon changes that are happening inside the particular container. And for the B3 SDK, what we have is something called the change feed processor, which is part of the B3 SDK. And you might, when I describe what it does, it might sound similar to what the Cosmos DB trigger for functions does.
Okay.
And that's because the Cosmos DB change feeds for functions uses the change
uses this, but now I can access it directly whether I'm in a function app or not.
Exactly. The idea is that you can create in the your applications and deploy them in whatever infrastructure that you want using this solution, this processor, and do it without the need of anything else.
Okay.
So the idea is that I will create an application. This application will, again, create, we have a Cosmos client instance, and I will actually define two containers. One which will have the items that I will be basically writing to, and another called the list container. The list container is being used to store the state. And the state is basically kind of like a pointer in time which is the current point in time where I'm reading the change feed. Again, if we go back to the change feed as a kind of timeline, the change feed processor will scroll through that timeline, and it will hook into the last point. So if there are anything going on or any new events, it will trigger your application right away.
Okay.
But if for some reason your application goes down or it needs to restart or anything,
it needs to know where to pick up.
Exactly. So that's the list container.
Okay.
And the thing is, the code is rather simple. We get the container we want to listen for changes on. We call get change feed processor builder, again, a builder pattern. We define which is the type of, or actually the C# type that we want to map our events to. And we define an delegate or a function. This function will basically receive the list of changes that are happening at a particular given time.
Okay. So
if I want to listen for changes, I get the reference of the container, call the change feed processor, and then I call a start async. So that what I will do is I will come here to one of my screens, and I will do, this is basically pointing to the source code of this project, that it's also available in GitHub, and we'll start a processor. The processor will start to listen for changes in the particular container.
Okay.
And the other thing is, I'm gonna show you, this one is the one in the lower end. Let's open several ones.
You can never have enough instances of the console open.
Exactly. So, okay, this one, it's processor. I always make processor. And I will have .NET run processor, and I will call it, oh, I forgot the name. See, this is live coding. And I will call this test1, and I will call this guy test2. So the idea of this having two instances of the processor is that the processor is smart enough to understand where there are multiple instances that are running the code and do a dynamic load balancing of the changes.
Okay.
And this is important because if those instances grow or shrink, because I need, these changes are basically being received in the container at a given rate, maybe 100 updates per second, or 1,000 or 1,000,000. If I have only one instance processing those changes, CPU is a resource that can be, constrained. I mean, it could be you can have so much CPU on a single instance. So what you can do is you can start scaling by creating more instances of the same code by using a different name, and the change feed processor will start to load balance the load across all existing instances.
So it understands by that registration that, oh, now I have 2, 3, 4, whatever listening,
Yep.
and I can start handing off to different instances.
Exactly. And if I'm gonna start a writer which will write, I don't know, 1,000 documents, or write. It wasn't that. It was writer. Live code.
You need to run your own help again. There you
Yeah,
go. It
see?
comes
My
back
own.
and.
Let's write 1,000 documents. And the idea is that the processors that are on the top half of my screen will start to receive those changes. See, there are some that goes to one of them instances and the other goes to the second, because there is a load balancing happening inside the application. And the final interesting thing is called the estimator. So it wouldn't be great if I have all this code deployed across many instances, and if I couldn't know, how, if I'm lagging behind, what's the rate at which these processors are processing changes. So there is one more thing that I can show you is dotnet run estimator, or not estimator. So the estimator, and let me quickly show you the code. It's very similar to the processor, but it's down here. The estimator is instead get change feed estimator builder. And the estimation, the delegate, it's going to receive a long, which will be the amount of changes that my current deployment of change feed processor instances is lagging behind of the actual point in the change feed. That means that, let's say my processors are processing 100 changes per second. But if the rate at which my documents are being ingested in the DB is 1,000 changes per second, then I can use the estimator to detect that lag and maybe provision more instances of.
So this will help you with smart provisioning, basically.
Exactly.
Instead of blindly, let's add more and see if we're catching up. This gives us a more scientific, if you will, approach based on measurements.
As you can see, I'm getting 0 changes. But if I stop the instances that we're processing and I then maybe write, I don't know, 100 documents, then the idea is that the estimator will see this and will start to report that now there are 100 changes to be read. Now let's start back one of our instances. And the idea is that since we were using this list container to store the state, now I'm getting all the changes that were not processed before. And I can see the estimator decreasing these changes as they are being consumed by the instances.
Makes sense.
So there's a way for you to create applications that react based on events. There is a way for you to measure how far behind these deployments are from the real thing. And you can do everything using the V3 SDK.
Nice.
And another feature, the next couple of features are new. They were GA'd last week. So the first one is transactional batch. The idea of transactional batch is when you want to create a unit of work, maybe a couple of operations. They could be create operations, they could be replace operations, it could be a mix of them. But for you, they represent one thing that it either commits or fails. In the past, we've seen users using store procedures to actually create these kind of things, because a store procedure execution is creates a transactional scope. So anything that happens in the store procedure execution either commits or fails.
Okay.
But the problem with the store procedure is that you need to put code in a store procedure that is not in your application.
Right, and if I'm a C# developer, I'm also writing JavaScript, right, for that stored procedure.
Exactly. And again, if you need to version your code, if there are things that need to change, you need to remember, hey, I need to version my stored procedure, or remember to update the logic in the stored procedure when I deploy my next version of the application.
Right.
So the idea of the transactional batch is to actually do that within the scope of your application. So let's jump on the code. What I have here is I have a container. Let's just press F5 to make it, more easy. And obviously make room for the code. So basically, this code will create a transactional batch. And we obviously start with the container. I have a container, and I want to create a transactional batch for operations within that container. And what I do is I define which are the operations that I want to do inside that batch. In this case, I create a show. I have one show for the on.NET, and I create 3 episodes, episode 1, 2, and 3 for the Cosmos DB SDK features. So So
based on that create transactional batch being on the container, I'm assuming transactions are scoped to a container. We're not crossing
Exactly. It's not the transactional scope is at the container scope. Yep. It's easier, I think, if I do it from the console. So let's do set the batch, and then run, and we can view the code side by side. Oops. So we'll press, and this will show, basically goes down to here. I get the response from the batch, and I can extract from within the batch, because the batch will say, OK, everything was OK, everything committed. But then I want to get the individual operations out of the batch to get their individual results. So what I do is I take the batch response, and I call get operation result at index, and the order of those indexes are based on the order of the operations that I define in the batch.
Okay.
And I can extract those results. And basically what I'm doing is, in this case, I'm showing the current last update of the show. And the next operation, what I will do is I'm going to update the show, and I'm going to create another episode. The problem here with this batch is that this create item will have the same ID as one of the ones that I previously created.
Okay.
So the expectation of this batch is that it will fail. So it will neither create this, and it will neither update the show with an updated last update date, basically.
Okay.
So it will basically extract the result. I can show that the result failed, and the replace operation, the one that was updating the display show for the show, it has a status code of failed dependency. That means that that particular operation went through, but the subsequent, the one that came after, resulted in a conflict. So this one can't commit because we are creating a transactional batch.
Okay.
And that's basically, and I can extract the results the same way that I did before. I can individually get the data.
So I don't have to shy away from a complex transaction. If it needs to be transactional and it's mutating multiple documents,
yep.
Not only can I wrap that in a batch, but I have that very finite control over what's causing it to fail if things go wrong.
Exactly.
Nice.
And finally, what I'm going to do is, this is basically an example of mixing and doing different operations. Now I have 3 replace operations that are updating episode 1 and 2 and updating the show because we are releasing it now, but the episode 1, maybe the air date is in 7 days and the episode 2 is in 14 days. But I also deleting episode 3 because I decided that I will only do 2 episodes.
We're fitting this in 2. So.
Exactly. So basically the operation went through, episode 3 was deleted, and the store, after I'm committing the batch, I can see that the store date is the one that I defined on the batch. So the idea of batch is you have this idea of having all these operations be all or nothing, and you can programmatically describe that operation. You can put that in your code, you can version it, and you don't have to rely on putting your code everywhere just to...
Right. And this is a question I get a lot when people talk to me about Cosmos DB is about that transactional. So now I'll be able to see with this SDK,
yep.
Here's how you do that.
This is GA, so if you pick the Cosmos DB client right now, that's already available.
Now, for viewers who may be working in other languages, I know there's other language SDKs.
Yeah,
is
we
this
are working
exclusive to .NET right now?
No, we are, since this is kind of like a support at the service layer, we are working to introduce these features in all our SDK flavors.
Okay, great.
And finally, the last but not least important one, it's called bulk. So let's zoom in a bit, just to make it more clear. So the idea of bulk is, and I like to have the code here. So the idea of bulk is, there are scenarios where you want to just, dump a big amount of data into the database. You need to do maybe a nightly processing of data. You need to just import a ton of operations at the same time on your container or your database. And in those scenarios, you need to squeeze the throughput that you have available up to the maximum.
Sure.
And reaching that point where you are getting all the throughput out, it's sometimes hard. You need to maybe rely on, in the V2 SDK, we have the bulk executor library, which is an external library that you need to add to your code, add more dependencies, and it has some restrictions in the amount of operations you can send at each time. But basically, bulk is defined as operations that need to just push through. So
yeah. I'm doing a lot in a little bit of time.
Exactly. And you need to squeeze all the provision throughput in your containers just to make that as fast as possible.
Right.
So what we introduced in the Cosmos DB V3 SDK, and it's already GA, it's this bulk execution mode. You can enable it through the builder, as we've seen before, with this build bulk with bulk execution extension, or you can simply add it to the Cosmos client options and toggle the feature on and off. The idea is that, let's quickly jump to the code, and I'm gonna, basically this is the same code for, I'm gonna run two different windows. One is going to save 300K items into my container with bulk, and I'm going to run the same code without bulk. And you can see basically the difference here in the code is basically toggling that bulk enable feature on and off depending on a command line attribute that I'm going to send. But what I want to show you is the difference in terms of performance.
So I recognize this code because one of the first shows I did on Cosmos DB, this was a couple years ago, I use an USDA database as an example, and nice. I pull that down, and it's all the food nutrients, and then I'm inserting it into the database to set it up. I could have used this feature back then.
For sure. It will certainly make things faster.
Yeah, so I'll have to revisit that project and update it to use the new SDK.
And the thing is, it's really simple. If you already have the Cosmos DB client code, it's just flipping a
switch. Yep.
So I'm going to give the no bulk option a head start. And
we can see where this race is going to turn out already.
Yeah, and obviously it doesn't let me open the other one. So let's give it even more time. And this is going to run the other one. So the idea, and I call it the magic, is what the Cosmos DB SDK is doing is, let's quickly go back to the code. What I'm doing here is I'm creating a list of tasks, and each task represents a create item operation.
Okay.
So I'm basically creating all these operations in parallel, and then at the end, awaiting them all. In a normal scenario, when you are using the SDK, this will basically trigger one service call per operation. So if I'm creating 300K tasks, each one to save one document, it will do 300K requests to the backend.
Okay.
And those, obviously, that
It's
means
noisy, a lot of RUs.
exactly. And if you think about it in terms of latency, those are 300K requests. So what the bulk feature is doing is just detecting that we have a lot of operations concurrently trying to go through the database. It will create these batches in memory and group these operations by partition affinity. I kind of like to think about these batches kind of like a train station. So we will pull in trains, we will fill those trains with operations, and we will send them away. And when one train leaves, another train comes. And this thing.
But I don't have to flip a switch or anything. This is all managed.
Exactly. This is all happening underneath while you just create the tasks that are happening in parallel. The key concept here is concurrency. You want to make these operations concurrent. So we create the trains, we send the trains. And the thing is, each train represents only one request to the database. So we are reducing drastically the amount of requests we are sending to the database. We are sending all these operations, and then we are resolving and unwrapping the response and basically wiring up to the original tasks. And this is important. So in a normal operation, in a normal C# operation, you do the create item, you get a task. That task represents the promise of a service request going back, going to the service and back. With bulk, we basically kind of like lie to you. We give you a task, but that task doesn't map to a service request. That task is the promise of us putting your operation in the train, sending that train along, that train coming back, we are unwrapping the result of the train and wiring the result to the task we gave you originally.
But from my code, it looks the same.
It's the same code.
Right.
And let's go back. And we can see the difference. So the one with bulk took 34 seconds, and the one with no bulk, same code, 2 minutes and 15 seconds. And again, this is my small notebook. This code is running locally in my machine, connecting to an account that is somewhere in West US. So obviously there is latency going on and everything.
Sure.
But we can see the real difference between sending all these 300 items through the wire with bulk and without bulk.
This gets me really excited. I have a blog post coming up now, so it's committed on air.
Awesome.
My loader took probably 20, 30 minutes on my laptop to load the whole USDA database.
Nice.
So I'm going to revisit it with this new SDK and see what we can get that tweaked down to.
Please give us your feedback.
I will, absolutely.
Awesome. That's basically all that I had. I really hope that you can try these features. We really need the user feedback because we take to heart what our users are actually doing, and we listen to your feedback. So the idea is that we need you to test it. We need to find which are the best scenarios. Maybe someone thinks about the different scenarios that we really didn't think about, and that makes, let us polish this feature even more.
Sure, so this is version 3
P3 SDK.
of the SDK. So go out, grab version 3 of the Cosmos DB .NET SDK. As Matías mentioned, we want your feedback. We want you to use these in your applications, share your candid feedback. This team is passionate about updating these SDKs to meet your needs. We just reviewed a ton of underdog features that provide tremendous value and just haven't been getting the press they deserve. So hopefully the word is out there. Share this with your friends. Thank you so much for joining us on another episode of On.NET.
Thank you.